to try your hands on absolute value equations, give it an attempt before you continue the video. Whenever you're ready, you can move on from here. Now that you've given an attempt for these problems, let's look at part A first. Part A is again a scenario where we don't have absolute value expression by itself yet. So the first thing we want to do is to isolate that absolute value expression by itself. And to do this, we can subtract 2 on both sides, and that would give me negative 3/4 x plus 5 inside the absolute value is equal to 2. And when we're given this part, this becomes very similar to what we did in part A of the example. So what we can do is we can really think about the absolute value expression inside can be equal to 2 itself, or it could be negative 2. So when we take the absolute value, it becomes positive 2. So from here we can say we have negative 3/4 x plus 5 is equal to 2, or we can have negative 3/4 x plus 5 equal to negative 2. And when we have this scenario, we can go ahead and subtract 5 on both sides to get negative 3/4 x is equal to negative 3. To get x by itself, we can go ahead and multiply the reciprocal, meaning we're multiplying negative 4/3 on both sides. And to get the result, we would have x is equal to, here on the right side, it would be a positive 4. And on the other hand, if I have the second option here, still the procedure is the same. We're going to go ahead and subtract 5 on both sides to get negative 3/4 x is equal to negative 7. And to find the result, I can multiply negative 4/3 on both sides. And as a result, we would get x is equal to positive 28/3. And these are the 2 possible solutions for our equation. Through this problem, I hope you can notice when we're doing equations symbolically, it gives us a lot more opportunities to try out different types of problems or solve different types of problems. They don't need to be whole numbers anymore. It doesn't require the precise graphing we needed for solving equations by graphs anymore. So with that, we can work with any type of absolute value expressions and still get the answer pretty quickly without the precise graphing. And for conclusion, we can say the solution set is 4,28/3, and it doesn't matter which one you put first. In this case, if they're in a set, the order doesn't matter. And lastly, for part B, I hope when you look at this problem, you got the attention pretty quickly that we have a scenario where the absolute value is equal to a negative value. So because this is less than 0, we're saying it's impossible for the absolute value to be less than 0, so there is no solution, or the solution set is the empty set. You can choose whichever statement you want to say. And that's how we solve this type of absolute value equations.